This topic is on basic tree diagrams. Let's look at question 1. A and B are two sets of traffic lights on road. The probability that a car is stopped by light A is 0.4. So that means that is 0.6. If a car is stopped by light A, then the probability the car is not stopped by light B is 0.7. So that is light B, so it's 0.7. So that means that is 0.3. If the car is not stopped by light A, then the probability that the car is not stopped by light B is 0.2. So that's 0.2, so that is 0.8. Now Mark drove along this road. He was stopped by just one of the sets of traffic lights. So he's either stopped by light A or he's either stopped by light B. Is it more likely that he was stopped by light A or light B? So let's work out the probability of being stopped by light A and not by light B. So stopped by light A, not by B. So that will be this branch here, because 0.4 times 0.7, which is 0.4 times 0.7, which is 0.28. Then let's look at is not being stopped by A, but being stopped by B, which is not being stopped by A, the one, and stopped by B, which is 0.6 times 0.8. So 0.6 times 0.8 is 0.48. So the second one is bigger. So we could say he is more likely to be stopped by B. Let's move to question 2. Bag X contains 9 blue balls and 18 red balls. Bag Y contains 7 blue balls and 14 red balls. List picks a ball at random from bag X. So let's put that in the diagram first. That's X, that is Y, that's red. We'll put blue at the first. Blue, red, blue, red, blue, red. And we have how many balls altogether? 9 and 18 is 27 here. 7 and 14 is 21 here. List picks a ball at random from bag X. So that could be 9 balls. Blue is 9 over 27, and 18 over 27. Then what she does is she puts the ball into bag Y. So the bag Y, the total number is going to increase to 22. So let's put that here. Right. If she picks a blue ball, if Liz picks a blue ball, then she will put that blue ball into bag Y. So bag Y blue balls will increase by 1. Right? So the blue balls in bag Y will increase by 1. So that will be 8. So therefore the chance of picking a blue ball by Mike will be 8 over 22. So the red won't change, so it's 14 over 22. If Liz picks a red ball, the blue won't change, so it will be 7 over 22. But this will go to 15 over 22 because the red will change to, in Y, 14 would have added to 15 because she picked a red ball and she put it in there. So that is the tree diagram. Now the question we need to prove, Liz picks a blue ball. The probability of Liz picking a blue ball is equal to probability of my picking a blue ball. So let's look at the probability of Liz picking a blue ball. So Liz picking a blue ball would be the one, 9/27, which is 1/3. My picking a blue ball would be, so that's one line. If you look at this, Liz picking a blue ball and my picking a blue ball, along the branches you multiply, so that will be 9/27 times 8/22 plus, that's another way, Liz picking a red but Mike picking a blue, the one, which is 18/27 times 7/28, 7/22. So we need to add them together. You can cancel it. Let's cancel. 9 will go in here 3 times. 2 will go in here 4 times. That is 11 times. So that will be 4/33, 11, 4/11. No, 4/33. Just 4/33 plus 9 will go in here 2 times, 9 will go in here 3 times, thus 2 will go in here 11 times, that's a 7. So that will be 7/33, which is 11/33, which is 1/3. So they are equal. Let's move to question 3. Question 3. Finlay plays 2 tennis matches. The probability that he will win a match and the probability that he will lose a match are shown in the probability diagram. Work out the probability that Finlay wins both matches. So that is along the branches anyway. Win and win. 0.7 times 0.7 is 0.49. Work out the probability that Finlay loses at least one match. So at least one match means he could lose both matches as well. So the possibilities are win and lose, win and lose, lose and win, or lose and lose. So win and lose is this, win and lose, 0.7 times 0.3, lose and win, 0.3 times 0.7, and lose and lose, 0.3 times 0.3. So that will be, this is 0.21, this is 0.21, this is 0.09. So therefore it will be 0.21 plus 0.21 plus 0.09. That will be 0.51. Let's move to the next question. On Friday, Greg takes part in a long jump competition. He has to jump at least 7.5 meters to qualify for the final on Saturday. He has to have 3 jumps to qualify, up to 3 jumps. If he jumps at least 7.5 meters, he does not jump again on Friday. So if he jumps once, 7.5 meters, he qualifies, so he doesn't have to try the other jumps. Each time Greg jumps, the probability he jumps at least 7.5 meters is 0.8. So that is 0.2. Assume each jump is independent. Work out the probability that he does not need to he does not need the third jump to qualify. So he could go up to second jump. So let's finish off this probability. The first jump he qualifies because he's already qualified. He already jumped 7.25 meters, so he qualifies. This one has got to do the second jump. So if he doesn't qualify on the first one, he has a second go. So he's qualified and does not qualify. So again 0.8 and 0.2. If he does not qualify on the second jump, he has another chance. Qualify, does not qualify. So that is 0.8, 0.2. So the question is asking you, work out the probability that he does not need the third jump to qualify. So in this here, he doesn't need to do the second one. And if you look at this branch and this branch, he doesn't need it. So these two, he doesn't have got to have the third jump. So let's put it together. So that is 0.8. Then the other one is 0.2 times 0.8. So that is 0.16. So what do we have to do now? We have got to add these two together. 0.8 plus 0.16 is 0.96. Next question. Question 5. Here are 7 tiles. Jill takes random tiles. He does not replace the tiles. Jill then takes a random a second tile. Calculate the probability that both tiles Jim takes have the number 1 on them. Okay, so let's see how many numbers in there. We have 2 1s. We have 3 2s. And we have 2 3s. So now we don't need a tree diagram. We could do without it. Let's see how we could do without it. So he doesn't replace it, right? So first time taking a 1 is 2 over 7 because you got 7 numbers altogether. 2 over 7. So if he has taken already the 1, the number has gone down. Number of 1s have gone down to 1. The total has gone down to 6. So therefore is 2 over 42, which is 1 over 21. So this is the first time. First, he didn't replace it, so the number gone down by 1 and the total gone down by 1. So that's the second. Calculate the probability the number on the second tile Jim takes is greater than the number on the first tile. So what are the possibilities there? He could on the first time, so let's write the possibilities. Try and do without the tree diagram. This is the second. So he could take 1 on the first. The second one has got to be greater, so he can't have 1, he has to have 2. Or he could have 1 on the first and 3 on the second. Then he could have 2 on the first. He can't have 1 or 2 because they are not greater. He can have 3. If he have 3 on the first, there's no other number greater than 3. So these are the 3 chances. So let's carefully write the probabilities now. Remember, first time it is always 7. Second time is always 6 because this hasn't replaced it. Does not replace. So we have how many 1s? We have 2 1s, 2 over 7. Then he has got second time he is taking 2. We have 3 2s, so 3 over 6. So that will be 6 over 42. This time again 2 over 7 first time because it's 2 ones, time 3 we have only 2, 2 over 6, that is 4 over 42. Third time 2, he has 3 over 7, then 3 is 2 over 6, that is 6 times 42. Now we can add all of them together. 642 plus 442 plus 642 will give you 16 over 42. So which is 8 over 21. Let's move to the next question. Question 6. Sally plays 2 games against Martin. In each game, Sally could win, draw, or lose. So 3 possibilities there. So let's do a tree diagram for that. It's easier that way. So it's 3 branches. One is win, one is draw, one is lose. So he's going to play 2 games. So we're going to do one more set. Right. Win, draw, lose, win. Okay, let's put the numbers there. In each game they play, the probability that Sally will win against Martin, so that is Sally, that is Martin. No, that is first game, the second game. Let's mark it that way. First, second game. So each game they play, the probability that Sally will win is 0.3. Sally will draw 0.1. That means losing is 0.6. So each game is the same. So let's put the numbers in. 0.3, 0.1, 0.6. Right, work out the probability that Sally will win exactly one of the 2 games against Martin. Exactly one of the 2 games. So that is this branch, win and draw, 0.3 times 0.1. Win and lose, 0.3 times 0.6. Draw and win. Now that is Martin winning. So that's the second game. So that will be, yes, that is correct. So it's 0.1 times 0.3. That's Sally winning still. And she could lose on the first game, win on the second game. That is this branch here. 0.6 times 0.3. So let's looking at it. Sally win on the first, second draw on the second. Sally win on the first, lose on the second. Sally draw on the first, win on the second. Sally lose on the first, win on the second. So if we put those together, that is 0.03, 0.18, 0.03, and that is 0.18. So it will be adding together 0.03 plus 0.18 plus 0.03 plus 0.18. So if you add them together, that will be 0.42. That's the end of the questions.